Hello, I'm Mrs. J, and welcome to my math class. Today we're going to cover section 12.1 of derivatives. When we're talking about derivatives, there's different symbols you'll see. Usually f prime of x is what we use, or y prime. Another one we'll use in later chapters is dy dx. It means the derivative of y with respect to x. Those are the main ones we'll see. The first rule is the constant rule. What the constant rule says is if f of x equals k, let's erase, where k is a member of R. This symbol means is a member of the real numbers, so it's just a number, then f prime of x is 0. So if it equals a constant, the derivative is 0. An example, if the function equals 10, which is a constant, the derivative is 0. The square root of 5, again, is just a number. It's a constant, so the derivative is 0. Pi is also a number, 3.14, 0. The power rule, if we have x to a power, and this is just saying that k and n are numbers, they're real numbers. To take the derivative, you multiply these two together, k times n, then you subtract 1 from your exponent. So if we had f of x equals 3x to the 4th, when we take the derivative, 4 times 3 is 12x, and we subtract 1 from the exponent, and we get 3. So it's 12x to the 3rd. Try another one. So we have 2x to the 6th. When we take the derivative, 6 times 2 is 12x. Subtracting 1 from your exponent, 12x to the 5th. How about f of x equals x? Remember, when there's no number, it's a 1. So 1 times 1 is 1. But when we subtract 1, we have x to the 0. Well, x to the 0 is 1. So it's just 1. Okay. Next rule. The next rule in this section is the sum or difference rule. If f of x equals u of x plus or minus v of x, what it's saying is if you have terms that are added and subtracted together, because remember that's what separates terms, you can do each one individually. So here we have 3 terms. We can take the derivative of each one individually. 2 times 1 is 2x. Subtracting 1, it would be to the 1st power. And you wouldn't have to show the 1. This one here, 6 times 1 is 6, and then it would be x to the 0, so the x drops out. This is a constant. It goes to 0. So it would just be 2x plus 6. This last one, notice these are in the denominator, and we don't have a quotient rule. So we would need to rewrite them first by bringing them up. Because remember, 1 over x is the same as x to the negative 1. When you move it up, it changes the sign of your exponent. So this is just x to the negative 1 plus 2x to the negative 2 minus 3x to the negative 3. And then we can take our derivative. Bringing the 1 down, negative 1 x to the negative 2, because we're subtracting 1. 2 times 2, negative 4x to the negative 3. and a positive 9x to the negative 4. So each one we were subtracting 1. Okay, one more. Well, this one has a radical. Just like the x's in the denominator we needed to move up to use our rules, when we have a square root, we need to rewrite it. Remember, a square root, whatever the root is, it is your fractional exponent. So that would be x to the 1/2. So we rewrite our x and make the radical becomes a 1/2. I don't know why it's doing that. And we'll leave the rest the same. Taking the derivative, half of 6, or 1/2 times 6 is 3x. We're subtracting 1. 1/2 minus 1 is a negative 1/2. Next one, bringing the 3/2 down, we have 3/2. X, subtracting 1, we get 1/2. Negative 2 times 5/2, the 2's cancel and leave a negative 5. X, when we subtract 1, we have 3/2. And that'll be your answer. And that's all there is to the first section.